Okay, good morning. So we start today's lesson. This is one of the main topics of this chapter, but of course I will not teach you something new. This mainly is the review. Of course, it's also in the book, but it is mainly review of what I told you before about trigonometric equations in Math 3C. But then you have to make yourself ready after this session to solve harder problems. So the first part, I just want to review what you have already learned. So first of all, let me define you this terminology, trigonometric equation. What do I mean by a trigonometric equation? First of all, what do I mean by an equation in mathematics? It means that you have an equality and then you have some kind of unknown in that inequality and you are supposed to solve it, meaning find all possible values of the unknown that turns the equality into a true equality. Yeah, so let me just, for example, if I say, what is this called in mathematics? This is called an expression or algebraic expression, but as soon as I put an equality here and then I put some number there, and I can ask you, what is this? This, you can say it's an equation because it includes an inequality and it includes an unknown. And when I say solve it, I mean find all possible values of x, so that when you replace x with those, if you substitute those values for x, the left hand side becomes exactly equal to the right hand side. So that's me. By the way, when I say solve, I mean something. Okay, I don't mean to guess. Or even if you want to guess, that's okay, but you have to show me that there are no other solutions except the ones that you guess, which makes it even harder sometimes. If you just, for example, if I ask you to solve this equation and you tell me x equals to 1, it is not wrong. It is clear that 1 is one solution here, because 1 to power 2 minus 1 is 0, so that's correct. But if you just write x equals to 1 and finish, this is not solution. This is not solving equation. Okay? But because you know that there is another answer, what's the other one? It's minus 1. Even if you say 1 and minus 1, I cannot agree that this is a solution, unless you tell me why you know there are no other solutions. Is that clear? In this case, it is possible. For example, we just had a theorem on the board that's called the fundamental theorem of algebra, which guarantees that every polynomial of degree n has at most n distinct roots. So yes, if you combine that with this argument of your guess, then it becomes correct. First, you say that I guess that these are the answers. I can show you that these are working by just directly substituting them there. And then you need, if you stop here, that is not complete. But if you say that, and on the other hand, fundamental theorem of algebra guarantees that every polynomial of degree 2 has at most 2 roots, then I am done. Because by that theorem, I cannot have more than 2, and I managed to find both of them. So it means that I solved the problem. Because this guarantees that minus 1 and 1 are all possible solutions. So that's extremely important for you to understand. When I ask you to solve, you should give me all possible answers. And usually these kind of arguments is not working. For example, fundamental theorem of algebra only works for polynomial equations. If you have different type of equations, it doesn't work. For example, if you have a logarithmic equation, it doesn't work because fundamental theorem of algebra is only for polynomials. So let me summarize that. So what this word solve in mathematics means find all possible answers. Okay? It is implicit in the word solve. So guessing will be out of the picture. Okay? So here you know how to solve it. So it becomes 2x. Then you move this one to the other side, and then you divide by 2. And then you should be able to prove that this is the only solution. So that's the solution. Okay, so that's the meaning of an equation. What is the adjective trigonometric referring to is, first of all, let me just write something else here. 2x plus sine of 23 degrees is equal to 5. Okay? here, this is an equation. I have an inequality, I have an equality, I have an unknown, so that is an equation. It is involved with trigonometry in some way, but still I don't call it a trigonometric equation, yes? Even though it is involved with trigonometry. Why is that? Because the unknown is not an unknown angle. In trigonometric equation, your unknown should be an angle, or should be the argument of sine, cosine, or tangent functions. Yes? So this is not a trigonometric equation. I want you to understand. If I ask you to solve this, in principle, I can give this one to a student in Math 1C and ask find x. Because what matters, sine 23 degrees is a fancy way of writing a number, but at the end, sine 23 degrees is a number. Whatever it is, I don't care. I'm looking for x. So I move this number to the other side. Yes? And then I'm looking for x, so I have to make x alone. I divide everything by 2. So I take this one and then divide it by 2. Whatever this number is the solution of that equation. So when I say trigonometric equation, I do not mean this equation. I mean an equation like this. This I will call a trigonometric equation. Yes? Because the unknown is inside the is an argument, is an angle of the sine function, and this is my unknown. So when you have your unknown inside the sine, cosine, or tangent functions, or a mixture of them, then you will tell me that is a trigonometric equation. So our topic for today's lesson is to learn systematically. It starts from today's lesson to systematically solve trigonometric equations. Okay? Is that clear? Yes. For example, do you think that this is also a trigonometric equation? Is this a trigonometric equation? Yes or no? Yes, because x is still an angle of sine. Yes? X is sitting in front of sine, and that's a trigonometric equation. So, this is the lesson that we want to start today. Everything that I am telling you, I have already told you in Math 3C, but let us try to understand it a little bit better. To be able to solve trigonometric equations, there are 4 standard ones. So we should know how to solve them. After that, you need to learn how to change a given trigonometric equation to one of these 3 standard forms. And because you have already learned these, how to solve them, then the problem is finished. But we will just talk about the standard ones today. There are 3 of them. One of them, number 1, is if you have sine of an unknown equals to a number k. The second one is cosine of the unknown x equals to a number k, and finally tangent of x is equal to number k. Yes? So these are the standard ones. We want to cover all of them hopefully today. For this one and that one I have some limitations, because we learned that sine is maximally 1 and minimally minus 1. So if I ask you to solve this equation sine x equals to 2, I can ask this, but the answer is there are no solutions. Yes? I can ask you cosine 5x plus 10 degrees equals to negative square root of 3. The answer is there are no solutions. Agree? Because minus square root of 3 is below minus 1. Cosine and sine are maximally 1, minimally minus 1. They cannot exceed these values. Okay, so here, for these 2 cases, I want you to know that k should be somewhere between minus 1 and 1. But for this one, I do not have any limitation. So this k can be anywhere from minus infinity to positive infinity. Okay, now let me start with a simple thing. By the way, the formulas that I am going to teach you today are not in the formula sheet. Okay? So either you have to reproduce the whole procedure that I'm taking you here every time, or you have to somehow memorize it at the end. So I would recommend you to just understand it so that if you accidentally forget about it, you can retrieve it. Otherwise, you will be a little bit in trouble, okay? So the first thing, let me start with an example. I would tell you that sine x is equal to 0.5. I intentionally use the numbers that I have in my memory, okay? So that make the teaching easier. I want you to solve this equation for me. If it was the Math 1C course, it was extremely simple. So what you do, you just write x is equal to sine inverse of this number, and then either you use your calculator, or if the calculator is not allowed, they have to give you numbers which are famous and you can find them in the table and then read the value. If you do that, it becomes 30 degrees. Yes? In Math 1C, this was the end of the story. But this is not the case here. Because I told you, when I say solve, I do not mean find one of them randomly. I want you to find all of them. This is, of course, one of them, but not the whole story. So what you need to understand is to go to the unit circle again. Okay? So what you have, one of them is 30 degrees. So this means that, let us assume that this is 30 degrees. Okay, and then you know that this point is the final point for this on the unit circle. So this point has two coordinates, x coordinate and y coordinate. X coordinate doesn't matter for our case because we are talking about sine. So y coordinate is the only one matters. But can you tell me what is the y coordinate for this case? The y coordinate is sine, and that is 0.5. Agree? But is this the only angle? Because when I ask you to solve, I mean find all of them. Okay, if I want to have sine to be 0.5, it means that, first of all, I have to be somewhere on the unit circle. On the other hand, I have to be on a point, at a point whose y coordinate is 0.5. One of them is this one, okay? And the other one is where? So let me just focus here. One of them is this one. Okay, so 30 degrees is definitely one of my answers. But I can be here and go one full round in the positive direction. Of course, the angle is increased, but because I will reach back, I will go back to the same point, the y coordinate will not change. So this means that 30 degrees plus one full round is also an answer for you. 30 degrees and these angles are different. This is 390 degrees. This is 30 degrees. They are different, but both of them are at the same point. So it means the sine of this angle, whatever it is, and this angle are the same. Yes? Is that clear? Okay, and then I can go two full rounds. Yes, I can have my 30 degrees, the calculator provided for me, and I multiply 360 degrees this time by 2. So it means that I go two full rounds about the origin. Do you agree? And I will end up exactly the same point. And I hope that you agree that this list can continue forever from this direction. But I can also go in the reverse direction. I mean that I can go here one full round, but in the opposite direction. So what does it mean? It means that I have my 30 degrees, but I have to go one full round, but in the opposite direction. Opposite direction, it means that I put a minus sign here. If I ask you what this number is, you say it is 30 minus 360, it's minus 330. So the sine of minus 330 is also 0.5. And then I can go two full rounds, yes? And this list will continue from the left as well. So let me tell you something. So far, how many solutions did I get? Infinitely many. But how many points on the unit circle I got? Exactly one. You need to understand that, okay? Because every point on the unit circle have infinitely many names, but it has only one x and one unique y coordinate. But no one writes it so long. It is better to formalize that. So I would say that x is equal to 30 degrees plus a multiple of 360 degrees. What multiple? A multiple n times 360 degrees. And then if people ask you what n is, because n was not in the problem in the beginning, I bring it in. Whenever you bring a new variable in, you have to define it. So I would say that n belongs to the set of integers. Okay? So be careful. If you write it like this, sometimes it is easy to fall into this trap that you just got one answer. No, you got one answer for each chosen value of n, but you have infinitely choices for n, so you get infinitely many answers for x, but it all corresponds with one single point on the unit circle. So these are the concepts. I am just repeating them because it will repeat itself over and over again for all these cases. Okay. But do you think this is the only scenario? Yes? This is something that I told you that it will not be in the formula sheet. So this generating this formula you should understand. So I am looking for sine x to be 0.5. So it means that I am interested to have the y coordinate to be 0.5. The y coordinate is 0.5 here. Can you tell me, is there any other point here whose y coordinate is 0.5? Yes, Abdul Manan.
150 degrees.
Where is that? How did you understand that? Yes, that's correct. So it means that it is the mirror image of this point with respect to the y-axis. Yes? If I ask you if the red dot is the mirror image of this black dot, if I ask you, can you tell me the y coordinate of this? You would say yes. What is the answer? It is 0.5 again. Let me just ask you the question right away. Are there other points whose y coordinates are 0.5? Y coordinates? No. Because y coordinate to be 0.5, so I have to make a distance of 0.5 from the x-axis. And this becomes a line. But this line can intersect the circle exactly at 2 points, not more. So that would be the end of the story. I will have only two dots, the black dot and the red dot. Okay? But now, as Abdul Manan mentioned, this is 150 degrees. Why? Because if you join these 2 points, be careful. By symmetry, what is the magnitude, what is the size of this angle? This is 30 degrees. But if I ask you what is the name of this angle, what is the name of this angle? If you say 30, that is wrong, because I told you before that everything should be calculated from this horizontal line to the point corresponding to your angle. In this case, if this is 30, it is a very easy guess to see that this is, as Matt he said, is 150 degrees. Yes? So this means that another solution that I want to write is 150 degrees. But is 150 degrees the whole story? No. Again, I can do that. I can go one full round and reach back. I can go 2 full rounds and go back to the same point. Or I can actually reverse my direction and go the other way around. So I would say that 150 is okay, but there are more. 150 degrees plus 1 times 360 degrees, or 150 degrees plus 2 times 360 degrees, and this we can continue forever on the other side, or I can go the other direction, 150 plus minus 1 360 degrees, and then I can continue this list. So if I ask you to write this, can I write this in one go, in one formula? Yes, you would say yes. This is what? 150 degrees plus a number which I can call m, because I have already used n, 360 degrees, and I mentioned that m belongs to z, and this is my other solution. Yes?
Shouldn't we change x to another variable? Or
No,
like
no,
x prime?
no, because that's the same x.
Okay.
Yes. I'm looking for all possible answers for the x. Even in this case, you don't need to change to m because they don't happen simultaneously. You say this is this one or that one. So these two solutions are not happening simultaneously.
Okay.
But to be on the safe side, it is better to change this m, but not x. If you change x, that is wrong, because I am finding this value for the same x which was given to me in the beginning of the problem. Yes? Is that clear? So this picture, these formulas are not in the formula sheet. So remember, the calculator or the table that you have is only capable of giving you this one. The whole expression and this one, this is what you need to write down. And I don't care if you just have it in your memory or you just visualize it every time. It's not very efficient if you want to visualize it every time. Of course, you have to have a good understanding. But the important thing, I have infinitely many answers. They are categorized into two groups. One, all of them corresponds to the black dot, and these all belong to this, correspond to this red dot. Okay? Okay, so if now what I want you to have in your notebook after understanding that, you help me to write it down. So I would say that one standard equation is that I have sine of a black box or whatever is equal to a number k. Yes? So what can I write here? I want to find this. I have two solutions, so this will imply that I have two scenarios going on. One or two. Okay, now can you help me to write the one? The first thing important for one is to find this. How did I do that? I found 30 degrees by calculating sine inverse of 0.5. But what is playing the role of 0.5 here? That k. So the first thing that I have to write, I would say that the box, the empty box, is equal to a sine inverse of k, but plus n times 360 degrees. And then I write n belongs to z in front. But this is not the only possibility. Or the box is equal. Okay, can you help me now? What should I write? In this case, we realize this is 150 degrees. In the general case, what should I write?
180 minus k.
Not minus k. 180 minus sine inverse of k. That number. Yes? 180 degrees minus sine inverse of k plus possibly m times 360 degrees, and then I would say m belongs to z. Okay, so that is the first standard equation. We are done. It is up to you. Memorize it or visualize. Of course, if you are good, visualizing it will not take that much time, so immediately can find it. Yes? We have the same scenario for cosine, so let us, without further ado, let us continue. That one, assume that I give you cosine x. Well, let me solve one example for you. So example. So let me solve this equation. Sine 3x minus 45 degrees is equal to, so let me put a 2 here, and then let me put a square root of 3 here. We want to solve this equation. Okay, let me emphasize here that these formulas that I have mentioned here are working if this is sine. So let me emphasize that this coefficient is 1. If this coefficient is not 1, you're not allowed to use the formulas immediately. So as you see, this is not 1. So the first thing that I have to do if I want to use the formulas on the board, I have to make this coefficient equal to 1. And that's easy. I divide by 2. Yes? So the first step is to divide everything by 2, so you get sine of 3x minus 45 degrees is equal to square root of 3 over 2. Yes?
This is the famous one.
Yes.
So 3x minus 45, it should be 60.
No, you have to be patient right now. We haven't started that.
But it says in the book.
No, it says in the book, but we haven't reached to that step yet. But if you write 60, then I will cross and give you 0. Because we haven't reached to that part. But this one, this is your black box now. And this one is your K now. Then you can see, if you do not look inside, then this emerges. When it emerges, I can use the formulas. So the formula tells me either the box, which is 3x minus 45 degrees, is equal to sine inverse of K. So what is sine inverse of K? Then you need to look at the table. Sine inverse of K is 60 degrees. Then I put 60 degrees here. It's extremely important. If you put 60 degrees there, it is totally wrong. But if you put 60 degrees here, it is totally correct. Understand or not? So because I have to put K, this number, and then sine inverse of that number is 60, not this number itself. Okay, and then plus n times 360 degrees, okay? But it is not finished here, because in the equation I am looking for x. It means that I have to make x alone. This equation is a standard equation. There is no sine or cosine involved in that problem. I want to find x, so I move this to the other side and then divide everything by 3 as usual. So this becomes 3x. I move this to the other side, it becomes positive 45, so it becomes 105 degrees. And then I have plus n times 360 degrees. And then at the end, I divide everything by 3. So if I divide 105 by 3, it is 35 degrees. And if I divide 360 by 3, it becomes 120 degrees. And here, at the end, I really, in the exam especially, you have to emphasize that n is an integer. Okay. So what is this? This is one group of solutions, not one single solution, infinitely many. Let me ask your understanding here. I told you that there are infinitely many solutions here. One of them is 35 degrees, if I choose n0. The other one is 120 plus 335, which is 155 if I choose n equal to 1. But let me ask you, how many points on the unit circle they represent? How many? I have to check. So you start there, 100, this one. Yes, I think it's 2. Yes, why is that? Let us see. So here you have 35 degrees somewhere. Okay. If I choose n equal to 0, for example, I end up with 35 degrees. If I choose 1, I go 120 degrees more. So which is 155 degrees, yes? So where is 155 degrees? So it's exactly opposite to this one, am I right? No. So 120 degrees. So what should I do? I go 120 degrees. 155 is a little bit smaller than here, okay? This one is 25 degrees, of course. Because if you go from here to here, it is 155 degrees. So by the way, 3 points, not 2 points. Yes? Because I have to go one more 120, so I will reach somewhere here. So you see, this is important to understand these things. So the angle, so let me write it like this, it is easier. So this angle between them is 120. Again, this angle between them is 120. And of course, this angle between them is 120. So there are 3. So there are infinitely many solutions. all of them are generated by the single formula that I have written here, but this single formula, in contrary here, you see, I had one single formula which only involves with the black dot. I had another formula if I wanted to consider this red dot. But this formula on its own corresponds to 3 dots on the unit circle. Yes? Is that clear or not? Because these are important. But the problem is not finished yet because I have an or here. So I have to go to the second option. So, by the way, these things makes the math for a little bit harder because you have to write a lot of things. So you have to be patient. So, or, what do I have? Number 2. Let us read the formula. The black box here, which is 3x minus 45 degrees, is equal to 180 degrees minus sine inverse of that k. But I already did sine inverse. How much was it? 60. So it is 180 minus 60. And then I have plus m times 360 degrees. And let us do most of it in our head. So 180 minus 60, 120. And then I move this one to the other side. It becomes plus. It becomes 165 degrees. But the problem is not finished. I have to make x alone. I divide everything by 3. How much is that? It is 55 degrees. And then I will have plus m times 120 degrees. Yes? And then I will say m belongs to z. And this is the other group of solutions. Is that clear or not? But how many points these are representing?
3.
Again 3, yes, because I have 120 degrees. So, for example, the main line is 55. 55 is a little bit here, and the other one is a little bit, I don't know, 55. I might have not a good picture. 175 is very close to this one. I mean, this is not a very good picture, but hopefully you understand what's going on. Okay, so I have other 3 dots. So in total, if I ask you how many answers we got, infinitely many. But how many points we got? 6. Okay? 3 of them are generated by this single formula. The rest of them are generated by that single formula. Is that clear? Okay, so I will not repeat these over and over again. What is important for us is finding a formula like this for the cosine case and for the tangent case. Okay, so let us just immediately try to do that. Okay, so now for the cosine case, let me also start with the same example. It doesn't matter. So let me write 0.5. And I ask you to solve that. Again, in Math 1C, what you need to do is just simple. You just write cosine inverse of 0.5, and then using your calculator or the table of values, this becomes 60 degrees. In Math 1C, that was the end of the story. But here we want to find all of them. So again, we have to analyze the problem in the unit circle. So what we do, cosine is related to the x-coordinate. When I want to make cosine to be 0.5, it means that I am interested in those points on the unit circle whose x-coordinate is 0.5. So how many of those points I can get? So you can say that, okay, here is 0.5 on the x-coordinate, but this is on the x-axis. I don't want to have it on the x-axis. I want to have it on the unit circle. This is very easy, yes? Because if I draw a vertical line so that I don't change my distance, then I will cut the circle at 2 points. Yes? If this point is 0.5, yes? These two, if I ask you, do you know the coordinates of these? You would say that I am sure about the x coordinates of both of them. Yes? Both of them are 0.5 degree, and I don't care what the y coordinate is here. Is that this idea is clear? So you see that for sine, these two dots were lying on a horizontal line. But imagining it for cosine, these two dots lie on a vertical line. Yeah, so that's the difference. By imagination, you immediately realize what's going on. Okay, now, can you help me to write the answer? For this case, okay, by the way, the calculator gave you 60 degrees. Where is it? If I just connect this one to this one, this is 60 degrees. Okay? So then this means that I will also have the same scenario. Not only 60 degrees is acceptable, but also if I go one full round, I will reach the same point and the same story. So let's make it short. So what should I write? I have to write this. Yes? And then n belongs to z. So that gives me one group containing infinitely many answers, but how many points corresponding to this blue dot here? Oh. But now it is easy to see what's happening, because what is the next angle that I am looking for? In the case of sine, it was its supplement. But let us see what happens for the cosine case. If I ask you what this angle is from measure point of view, it is easy for you to answer by symmetry. How big is this?
60.
60. But if you say this is also 60, that is wrong. There are two names for this. One name, some books use again the standard way. They start from, you have to always start from here. But if you go in positive direction, what is this angle called? 300. But if you go in this direction, what is this angle called? Minus 60. And that's a matter of convenience which one you want to choose. It doesn't matter. I always prefer to use minus 60. Okay? Because, let me write, for example, if you write this in the exam, that is 100% correct. You can write this. But of course, with the same story, I can go one full round in each direction, a multiple of full round in each direction. So let me just use letter M this time, and then I emphasize this one. So if I give you in this exam, and I ask you to solve it, if you write these two, that's 100% correct, you get the full mark. Okay? But I myself prefer to use the negative one, and as I see in the book, they are also using the negative value. So instead of writing that, I would write 60 or negative 60. Yes, that is easier to write it down, and that is good. Actually, it fits to the human nature, and that is indolence. Yes, so it's easier to write it down. That's up to you. I learned for cosine, I have learned it in that way to put plus and minus, but if you want, you can write that one as well. Yes or no?
Yes.
Okay, now can you help me to write something similar for the cosine case? So, let me write the second formula today that we want to have. So, I have cosine a black box equals to k, and then let me also emphasize that this coefficient has to be 1. If it is not divided by that coefficient first. So, if you use this plus or minus version, it is easier. So the black box is equal to, I would write plus n times 360 degrees, and I would write n belongs to z. How should I fill this gap now? According to what you learned, what should I write for the gap? Yes?
Plus minus cosine inverse of k.
Yeah, exactly. Thank you. So that is up to you. How do you want to remember that? But you have to know this. But by the way, that is very common. For example, this is what I'm saying. This is good to know because if you want to check your solutions, you might solve this equation and write these two answers. But when you go and check your answer at the end in the faucet, you see that they have written this. I want you to understand that you haven't done any mistakes. These discrepancies between the solutions that you have and the one in the book might be not very serious. It might be just apparently there. But to make this clear for you, let me talk about this a little bit deeper, but before going to the third one. So if I ask you to solve this equation, let us see how it goes. Okay? First of all, I want to make sure that you are not being tempted to take these two out. It's not possible. This means, let me make this clear. If I give you this, and if I give you x is 30 degrees, and I ask you what is the question mark, how should you act? Assume that I give you the calculator. How do you do? The thing that you have to do, you have to multiply your angle by 2. It becomes 60 degrees, and take the sine of 60 degrees. If you if you do that, the correct answer to this is sine 2 times 30 degrees, which is sine of 60 degrees, and it is a square root of 3 over 2. But if you mistakenly take 2 out and then put 30 here, sine of 30 is 1/2, so it becomes 2 times 1/2, which is 1. And you see that they are not equal. This is the correct answer, this is the wrong answer. So be careful, you are not allowed to take these 2 out. It's not correct. Okay? We will talk about this. This is one topic that you haven't studied in Math 3C. What happens for these 2 we will discuss later. Okay? But for the time being, 2x, sine of 2x means, if you want, this is common that they don't put pair of brackets, but if you want, I can emphasize on that. I can put a pair of brackets around that. Okay, but that's a good example. Please listen to see that what can happen between your solutions and the given in the faucet, in the solution manual. If you want to solve that, the formula is still on the board, yes? Here. So the black box, the box that I have here is this guy. I will give the role of my box to this, and I give the role of k to this. Yes? And then what I do, I would write it like this. I would write option first, the first option. The box, which is 2x, is equal to sine inverse of 0. By the way, if you don't mind, let me calculate sine inverse of k of 0 here. Sine inverse of 0, it's also 0. So this means that, you see, when I go here, sine inverse of k, in this case sine of 0 is 0. Sine inverse of 0 is 0, so I don't write it down. It becomes n times 360 degrees. And because I am looking for x, I divide everything by 2, yes? So this becomes n times 180 degrees. And then, of course, I emphasize that n belongs to 0, okay? Nothing is wrong about this, so that's correct. And then there is another option, of course. 2x is, can you tell me what is this one, Laura? What should I write here? 180 minus sine inverse. Sine inverse in this case is 0, so 180 minus 0 is just 180. And then my plus n times 360 degrees, and then I divide everything by 2. 90 degrees plus m times 180 degrees. And then I would say m belongs to 0. Okay? If you write this in the exam, and if this exam has 2 points, if this question has 2 points, I give you 2 points. Yes, so that's completely correct. But you might not find this one in the faucet. And that's what I'm trying to tell you. You might think that you have done something wrong, apparently you haven't. I just tell you that this is completely correct. But let us understand what is going on. This formula is taking care of 2 dots on the unit circle. Okay, so what are those dots? For example, I have to choose n to be an integer. If I choose 0, I will end up 0. If I put 1, it becomes 180. If I take 2, it becomes 360, 3, 5. So this is just these two dots. Yes? But what about these? If I put 0, it becomes 90 degrees, it's here. If I put 1, it becomes 90 plus half a circle more. So it will end up here. If I put 2, it becomes 360 degrees plus, I will end up again here. Yes? So this means that this formula is taking care of the black ones. This formula is taking care of these blue ones. Nothing wrong about it. But sometimes it is possible to write them more compactly. Can you give me one single formula which takes care of all of them simultaneously? There is not. I want you to understand. There is nothing wrong about writing these two in this form. But in this form, you are using two formulas. One formula generates these dots. This formula generates these dots. This formula has nothing to do with these dots. This formula has nothing to do with these dots. Yes?
You could write x equals to 90 plus m times 90.
Okay, let us say. So exactly. So is that correct? So what Gustav is saying is that instead of considering this, I will write 90 plus
m times 90.
m times 90. Let us see. How many of you agree with him? So he's saying that if I combine these two formulas, I can write them in one compact form.
Oh, you
That's
missed
it.
the first point then.
Am I?
Yeah.
Am I missing the first point?
Well, not eventually.
Not eventually, and that is the good word. Not eventually, and that is what matters. It doesn't matter which one I start first. So if you write this, I have to give you the full mark again. Why? Because if you choose 0, you end up here. If you choose 1, you end up there. If you choose 2, it will end up here. And every time you go 1/4 of the circle forward.
Yeah.
Yes? So this is clear that if I start from here, after 1/4 I will cover this. After another quarter I will cover this. Another quarter I will cover this. And then I will repeat the process. So this one single formula is taking care of all dots simultaneously. But the point is that why should I bother even to write 90? Yes? Do you agree that I can write it more beautiful? I just write m times 90 degrees, that's it.
Yeah.
That is better, yes? I mean that you see that there is no one unique way. If you write this, 2 points. If you write these 2 points. If you write these 2 points. But which one is better? It's probably the more compact one. So if I want to write it, then probably you will find this in the faucet. So I want you to say, nothing is wrong with what you have found. But the more efficient way of writing is this one. Some cases it is possible. By the way, this is in some cases. Otherwise, I don't bother to write 2 cases every time. If I was able to combine them all the time, I would combine them and give you one single formula there, yes? It is not possible to combine these two every time. But sometimes, by coincidence, it is possible. But that's a good example to have in mind that you can express your angles in different ways. Yes? Okay. That's what I'm saying. Now, the last part of the lesson is just understanding the tangent case. And then we will. Okay? So that is a crash review of what we learned actually. It's not in Math 3C. Okay? So what about tangent? So let me solve the problem of tangent together. So the problem of tangent, let me just write it down as an example. Let me follow the same method. So I would write the tangent of x. Let me make it the square root of 3, okay? Again, if it is a Math 1C lesson, it's extremely simple. What's the answer? X is equal to tangent inverse of square root of 3. And I intentionally gave these numbers that I have in my memory. The tangent inverse of that is again 60 degrees. Okay, but that's not the whole story. I want to find all of them. Okay, so I go to the unit circle. Yes, you already have enough experience to help me to do this one out. Okay, so 60 degrees is, for example, here. This is clear. But the point is that I'm not looking for all dots with x coordinates the same or y coordinates the same. Because do you remember what was the definition of tangent? Tangent was y coordinate divided by x coordinate. So this is a little bit harder because in the other cases I was just looking only for x coordinate or the y coordinate. But here what matters is the ratio of the y coordinate to the x coordinate. So what I have to do, try to see, okay, this point has x coordinate as y coordinate. Do you know? I don't know what is the x coordinate, I don't know what the y coordinate, but I know something. I know y coordinate over x coordinate is what? Everyone, is what? A square root of 3, yes. This I know. Okay, now can you tell me, is there any other point on the unit circle? But let me first write this. So 60 degrees is one of the angles. But again, is 60 degrees the only thing? No, because I can go 1 full round, 2 full rounds, the same story. So I would write n times 360 degrees, n belongs to 60. So this formula is taking care of these dots. This is easy, yes, as usual. But the point is that if there is other point and we are not considering this, we are losing something. We have to be careful about that. Now my question for you, do you think I can find another point on the unit circle whose ratio of y to x is exactly square root of 3?
Minus y minus x.
Minus y minus x, which is where?
Like
Exactly the mirror image with respect to this point, or the mirror image, the reflection of that with respect to this point. Why is that? Because y over x is equal to a square root of 3 means y is equal to a square root of 3x. Do you agree? This can be translated. But if I ask you what does this represent?
A line.
A line which passes through the origin. Okay? So then this line will intersect the circle at 2 points. So there are no more points, but there are exactly 2 points. Exactly the other one is the opposite. Yes? So let me just review this. If I ask you, can you tell me the coordinates of this point? If I give you these, the answer is yes. If I give you x and y, what do you write for this? Minus x minus y. Is x coordinate changed? Yes. Is y coordinate changed? Yes. But is the ratio changed? No, because the ratios are still the same. But the ratio is minus y over minus a, I agree. But it doesn't matter because it becomes y over x. So this means that I have exactly 2 points. Yes? Exactly 2 points with that property. Can you tell me what this angle is? Which angle corresponds to this dot? What angle? You have to start from here and go up to this. What this angle is? 240, yes?
Yes.
That's 240. So what can I do? So I can write x is equal to 240 plus m times 360 degrees. I don't explain this anymore because you know that you go full rounds, yes? That's it. This is the solution for the tangent case. Okay, so let me just review. For the sine case, we had angle. And do you remember? The mirror image with respect to y, which is 180 minus that angle. The main angles are these two. For the case of sine. Do you remember? For the case of cosine, do you remember what was that? For the case of cosine, what was that? We could write it in 2 ways. We could write it either theta and 360 degrees minus theta, or we can make life easier, plus and minus theta. For the case of tangent, what do you see? You have an angle, and the other angle is The other angle is 180, but plus theta. Okay? Understandable?
Yes.
So this is the thing that you have to have in mind. But the good news is that for tangent case, I can always combine these two into one single formula. For the case of sine and cosine, I was not able to do it all the time, even though I had some exceptions. You see, in that exception, I were able to combine these two formulas in one single formula, but not always. For cosine, I can, but not always. But the good news is that for tangent, these two can be combined into one single formula. Can you see why? In this case, this formula is taking care of this dot. This formula is taking care of that dot. But can you tell me a formula taking care of both? Instead of going one full round, because if I go one full round, I will lose this. If I start from here one full round, I'm losing this and I reach the back point, yes? If I start from here, go one full round, I will go back to the same point, I'm losing this one in this case. But how can I consider both, yes?
60 plus n times 180.
Yes, instead of going one full round at a time, I go half a round at a time, then I will cover both. And this is always possible for the case of tangent. So then it means that these two formulas can be combined into one single formula. This becomes what? It becomes 60 degrees. Instead of remembering to put 180 plus, I just remember to put this. This is the price that I will pay for that. This becomes m belongs to z. So remember, for the case of tangent, I can always combine the formulas into one single formula. Yes? Okay, so let me write the final formula and the lesson is done. So can you help me now to write the formula for the tangent case as well, with the black box and things like that? Okay, so what I do is this. I would write this one for you. Tangent of a black box or whatever is equal to k, and I emphasize that this coefficient is 1. Okay? Okay, now how many formulas I need in this case? Only one formula. So the box is equal to. Here, as usual, you put tangent inverse of k, but if you want to write it in the one formula format, you remember, in contrary to sine and cosine, that we always put 360 degrees, we have to put 180 degrees. So that is the final formula for today's lesson. I can give you an example and then we are done. So for example, tangent of 2x is equal to, say, so let me write 1, for example. We want to solve this. So what you do, you write 2x is equal to tangent inverse of 1 plus n times 180 degrees. But tangent inverse of 1 is famous, it is 45 degrees. And then I have to divide everything by 2. So dividing this by 2 is 22.5 degrees, and then n times 90 degrees. And one question, how many dots you will get on this, for this formula, on the unit circle? Because I got infinitely many answers. By the way, I forgot to write n belongs to z. So I got infinitely many answers, but there are not infinitely many dots on the unit circle. What are those dots? Yes? 4. 4 times 90. So there are 4 dots for completing. That is the whole story that in principle you should learn in Math 3C. So that is extremely important. And still, every now and then when I correct your papers, I see that you only write this answer. Okay? If I am going to ask you to solve this as 0, don't even bother to write it down. Okay? Because you have to write it in a complete form. Any questions? Okay, so we end the lesson, not the lesson, the teaching here. The lesson ends at the usual time. Questions? Yes?
I mean, so for the 10 from that, you probably want to add that n belongs to the set of integers.
Yes, yes, thank you, thank you. It's always, it has to be mentioned. Thank you.
Do we get minus point if we don't express n belongs to the set of
I will try to do that, yes.
You will try.
Yes.
What does that mean? So like if you feel
So it
bad
means that
for-
if that's change your destiny, if you are going to fail the course because of that, probably I will not do that. I'm not that
Okay.
cruel, yes.
So you'll be nice about it.
But if yeah, so if you are not on the border, I will say, and you need to remember this, okay? So when the lesson ends, do you know?
40.
40. Okay, so you have 20 minutes. I will update the Google Classroom here now.